morning, class.
Good morning.
Good morning.
I heartily welcome you to our second lesson concerning the Comenius project. You had one lesson on Monday already in chemistry. I hope you remember everything. And our topic is effective science learning with all senses. And maybe you remember from Monday, which we saw, we had a box with a lot of fruit inside, and now I brought this fruit again. And I have here got this basket of fruit. Okay, Hannah.
How do they get their colors?
Okay. How do they get the colors? Okay. What else did we ask?
What are the differences between the containing acids or something?
Okay. This was acidity. Okay, that's one thing. What else? Lisa?
What about nutrients?
The nutrients inside. Okay. Okay. Today we are not in chemistry. We are in physics. Which one would you say is more a topic for physics? Which one of all of them? Johannes, if you see 1, 2, 3, 4, which one fits more to physics?
Maybe colors.
Maybe the colors. Okay. The colors is a topic about physics, and that's what we want to do today. We want to check what about the colors of a fruit. Okay. The colors will be our topic, and yeah, now we have, which colors do we have here? You know, I'm not.
Yellow. And this is green. This is also yellow, and this is a little bit reddish, maybe. And yellow.
Okay.
And lychees, they are a little bit purple.
A little bit purple. Oh, nice. We have even purple inside. Okay. We want to do this today in a certain manner. We have prepared some stations. In total, 6 stations where you can work now, and each group works on its station. We will get now the task what you have to do in this station, and we work on this station 10 to 15 minutes, and then we give a signal and we change the station. And when we have changed maybe 3 times, that will fit into the lessons, then we will try to get the information together, and maybe we know more about what color is and where the color of an orange, of a banana or a kiwi comes from. Okay, we have the
And yellow. And while during rotating it has the color green.
Yeah, but the green's lighter than what.
Yeah, light, very light green.
So, wir wissen nicht, was wir machen sollen. We're supposed to tell which color is combined, or which. Can't you cut those parts out? Okay. Yeah. So, no, just
blue and yellow
are is green. So green color, so yeah, like that.
While turning, the wheel becomes green. Light green.
Yeah. But during
and then red and yellow is orange. Yeah, you can clearly see that it's orange. Das ist aber gut.
What colors do we see? Red,
Yellow.
green.
Yeah, but it and then yeah, but it was the same colors.
Yeah.
So I think we first read down we took two prisms, one with 3 prisms and one was just 1 prism, and there was no battery effect, but with this you can see much more color.
Du kannst hier die genau View oder die Window. Please click close.
Das ist wirklich gut. This is a house. You can check it with it. Aber erstmal.
Wie, Achtung, genau.
Und wenn ihr fertig seid, dann könnt ihr eigentlich schon mit einer anderen Station tauschen, die auch fertig sind.
Aber Frank, weißt du, jetzt
Only the red and green fast, like really fast. When you do it like this.
This isn't working. And we made our own as well.
Okay. So then
Blaue Platten mal gleich als rot wird dann heller oder dunkler. Aber wie
Immer auf grün, ich will mal wissen,
Put
was
in
da
one,
dazu kommt.
one word. Are you adding the colors or subtracting them?
Adding.
Yeah.
Das habe ich gemacht, aber...
Das hier ist Fake.
Warte, mach mal das da und dann mach nochmal dieses Blinken.
Ist kaputt, Luca.
Dass du dann so einen Regenbogen hast. Jetzt.
Ja, warte, versuch du noch. Versuch du noch den Regenbogen.
Michel. Michel. We're supposed to find out using the color picker on the laptop how much % of which color is in which part of the food. So by strawberry we see that it has 89% red, 21% green, and 30%.
Light projector. Here we have a lens, and here we have a prism, and here we have a screen. We can, from the light projector, here comes the light into the lens, to the prism, and in the prism, the light gets red here and changes and becomes the color of the rainbows.
Yeah, our observation is that after the light is filtered through the it hits the screen, and when it hits the screen, we can only see the rainbow colors, which are purple, blue, green, yellow, and red.
And so our conclusion was that the prism refracts the white light and splits it up into all its elementary colors, which are the elementary colors of the rainbow. And those are the red, yellow,
Elementary colors. Okay, of the rainbow. How many colors did you identify? How many?
So we had the station with the LED strips, and well, we looked at the LED strips in the with the white light, and we came to the conclusion that there are 3 pixels in each diode or strip. There's a red, green, and blue pixel in there. I don't know if it's visible in the okay, not important. And okay, and then we did different colors. We put different colors on there to see which diodes would be activated from the red, green, and blue. For the red light, we had just red, obviously, and blue, we just had blue. For the white light, all 3 sub-diodes were activated, the red, green, and blue. And for the pink light, the red and blue, and for the yellow light, the green and red. Yeah. So
We then had which other colors could we produce with these diodes, and we came to the conclusion we could produce purple with the blue and red diode and orange with the green and red diodes. And we had to complete the sentence. Red, green, and blue are the 3 primary colors. All colors can be produced by mixing different amounts of these 3 colors.
Thanks very much.
In our presentation, we measured the RGB value of foods. So first, the RGB means the amount of red, green, and blue light in some. 0 is completely no light, so black, and 255 is white, so the brightest. For example, clicking in the orange at that part, it gives us a red value of 255, green 155, and blue 17, and in percent, red 100%, green 61%, and blue 7%. So, and clicking here, it gives us a completely different value, so you should make an average.
Yeah, we have an overhead projector with a plate with 3 colored central discs. They're green, blue, and red. And this is a mirror plate, and we projected them to there. And if you mix those three colors, white is in the middle, so you can see if you mix the three primary colors, white appears.
And if you mix red and blue, purple appears, and if you mix red and green, yellow appears. And if you mix green and blue, then light blue appears.
Yes. Yeah. So we have a turning wheel, a stand, and a color plate made by Newton. And if we turn it with 8 turns per second, the colors mix, and we see a light blue color.
Yes.
And we have this covering plate, so we can cover each color, and you can see which color turns on.
Yeah. When you cover yellow, colors turn to light blue, and if you color light blue, then the colors turn to beige.
Yes, and when you cover purple, you get the you get also beige. When you cover the color green, you get the color white. Thank you.
Okay, did you show it to the other side?
The overhead projector projected these three colors at the first, magenta, cyan and yellow, and if they overlap, magenta and cyan result dark blue or purple, and cyan and yellow equals green, and magenta and yellow red. And this is called subtractive color mixing, because the colors overlap. When they overlap, we only get the subtracted color of these plates. The same can be shown with the stars. For example, yellow, here you see yellow and blue, and if you put these two colors over each other, you get green.
And in the middle we got black. Can you also get black with the stars or not?
Yes. We have to get the other one. No.
No, that one. Okay.
So we added blue, yellow, and green, and red, sorry, to get black.
Now you just said you added, but it's not an
But
added.
actually it is subtracted.
Okay, because the white light comes through the overhead projector to our eye and it's subtracted. You see only the result, which is the rest, and there's nothing rest. Nothing rest means black. Okay, thanks very much. Any questions to book number 6? Okay, thanks very much.